Hello. In this video, we're going to be continuing to look at key features of quadratic functions. So the first thing I want to remind you of is that when we talked about translations of functions in the past, so for instance, if we had a function f of x plus 2, that would be slid or translated to left from the function f of x. The x plus 2, because it's in the parentheses, does the opposite of what you'd think. So inside affects the left and the right. It goes left 2 units. If we have f of x minus 5, the minus 5 in the parentheses, again, does the opposite of what you think. It affects the left and the right, though, so it would go right 5 from the original function. The other part here then is if they're outside the function. So if we have f of x and then plus 1 outside of it. These affect the up and the down. So we would actually slide this up 1 from the original. When it's outside, it does exactly as you would expect, affecting the up and the down. So then if we have f of x minus 3, where the minus 3 is outside the parentheses, outside the function, then we would slide this thing down 3 from our original function. Okay, let's use this information to help us do these few examples. So our directions ask us to determine how each graph would be changed from the parent graph of f of x equals x squared. So in number 1, we have x minus 6 quantity squared. The minus 6 is inside the function, so the minus 6 happens before the squared does. This means it affects the left and the right. And remember, we always do the opposite of what it suggests. So since it affects the left, right, and it's a minus 6, we actually slide this right 6 units. So wherever it's sat before, and this is our parent function x squared, so our basic parabola is just going to be slid to the right by 6 units. Number 2, here we have the quantity x plus 10 quantity squared equals our function. Again, it's inside the parentheses, so it affects the left and the right. We would do the opposite of what it suggests. So this one, we're still going to slide, but this time it's going to be left. Because it's a plus 10 inside the parentheses, we go left, and we go left 10 units. Okay, number 3. Here we have x squared, and then plus the 8. So because this is outside the function, it is still going to slide, but this time it's going to be up and down. And it's positive, so we do the exact same thing as it says, as we would suggest or as we would think. So here we're going to slide up. The plus 8 indicates an up, and it'll be up 8 units. Again, outside the function, we do exactly as what we think, so the plus 8 makes me think up as opposed to down, so up 8. Next one, x squared, then a minus 4. The minus 4 indicates that, again, outside the function, it's going to be up or down. The minus means down. So here we're going to slide down 4 units. All right, number 5, last one on this slide here. Notice we have 2 different things going on. We have both the minus 7 inside the parentheses and a plus 9 outside the function. So again, 2 things going on here. So the inside indicates the left and the right. And again, we do the opposite. So here we will slide right 7 units. But the plus 9 then moves us again. So this time we will also slide, and we will slide up 9 units. The plus on the outside, again, we do the same direction as what we would think. So plus 9 means up 9. All right, let's apply this to actually being able to graph these. In number 6, we're going to use what we talked about in number 5 to sketch our function x minus 7 quantity squared plus 9. So we know that everything has been slid left. So we remember we said we were going to slide, oh, sorry, it was going to be right 7 and up 9. So our typical parent function of y equals x squared sets its vertex at 0, 0. Well, that vertex is then going to move right 7 and up 9. So it's going to land roughly there. So we know our vertex is at 7, 9. Now to graph the rest of this, I'm going to make an xy chart, or rather an g of x chart. So one easy thing to do here, we know one point that's already on this, and that's 7, 9. And since that's the vertex, and that should be kind of what we'd call the central point, like the point of symmetry on this, I'm going to stick this right in the center of my t-table. So 7, 9. From there, I can just kind of pick numbers to plug in place of x. What I'm going to plug in are two numbers that surround 7 in each direction. So 5 and 6 are two numbers less than 7. 8 and 9 are two numbers bigger. From here, we would evaluate whatever g of x is by putting these numbers in. So for instance, if I were to do 5 minus 7 squared plus 9. 5 minus 7 is -2. -2 squared is 4. 4 plus 9 gets me 13. All right, let's plug 6 in. So we'll do 6 minus 7 squared plus 9. 6 minus 7 is -1. -1 squared is 1. Plus 9 makes 10. Okay, now we're going to put the 8 in. So we have 8 minus 7 quantity squared plus 9. 8 minus 7 is 1. 1 squared is 1. Plus 9 makes 10. And we finished up by putting 9 in. So 9 minus 7 quantity squared plus 9. 9 minus 7 is 2. 2 squared is 4. 4 plus 9 is 13. So I can graph these other 4 points here. I can't fit 5, 13 or 9, 13 on the graph, but I can find 6, 10 and 7, 10. We kind of see the start of what our parabola would look like, and there is a good sketch of it. Okay, so that is how we can use key features and vertex form to graph a parabola. For now, we are done.